This section is on the Pythagorean theorem, so I'll go through and explain it and then do several examples, look at a couple applications. So first of all, we have a right triangle here, ABC with the right angle at C, and here we see how the Pythagorean theorem works visually. You take this side and make it into a square, take this side and make it into a square, take the hypotenuse, the longest side that is opposite the right angle, and make it into a square, and it turns out that the blue plus the green is equal to the red, and if you rotate this around, you can see that this is indeed an area of 25. This was 9, 16, 25. 9 plus 16 is 25. So here's our theorem. One leg squared plus the other leg squared is the hypotenuse squared, or you could say the shortest side squared plus the middle side squared is the longest side squared. This is the converse. If this is true, the triangle is right. We'll look at the converse a little more later. Besides squares, you can really do this with other regular polygons, it turns out. Any equilateral triangles or squares or pentagons or even semicircles. So not that we really do much of that, but it works for all of those. And if we move the triangles around in shape, but as long as they're right triangles, this always works. That the a squared plus b squared is always equal to c squared, as you can see. So a couple applications. Here we have a kid flying a kite, and you can set up a right triangle from that and basically use that as a right triangle to figure out if you knew this distance here and you knew the length of your string, what the height was. And then here we have a 15-foot ladder. This wall we consider to be a vertical wall, so it's a right triangle right here. And so you can find the height by using the Pythagorean theorem. You say 9 squared plus h squared is 15 squared. And as long as we can move this around, and it's always a right triangle, so we can always be using the Pythagorean theorem here in order to find the height if we know how far away the ladder is and the length of the ladder. Okay, so Pythagorean theorem is used with the right triangles only. The side on its own is the hypotenuse, the longest side opposite the right angle. Now that will always be the longest one. So if we have a here as a leg, b is a leg, and c is the hypotenuse, then a squared plus b squared is equal to c squared. Now, because we're squaring so many things, it's important to recognize things like perfect squares, and so let me point some of those out to you that are useful for you to know, particularly when we're simplifying radicals. So here's a list of several integers and their squares. So if you needed to, you can go back and pause to take a closer look at this list, and I show a few larger ones down here just because they come up more often, 24 and 25, because you see those in what are called Pythagorean triples. A Pythagorean triple is a set of numbers such that the three numbers together are whole numbers and they work in the Pythagorean theorem. So 3, 4, 5 is a Pythagorean triple because 3 squared plus 4 squared is 5 squared. 5, 12, 13 works because 5 squared plus 12 squared is 13 squared. So it's useful to know these just because it'll make your life easier when you're trying to solve some problems. In addition to these, there are many more, but the point I want to make with this column is that you could take any one of these Pythagorean triples and multiply it by a number and get another one. So we take these numbers, multiply it by 2 to get 6, 8, 10, that works. We take these numbers, multiply them by 10, 80, 150, 170, that works. You can always take one, multiply it by a whole number, or even say multiply it by half to get another Pythagorean triple. Okay, we're going to get some radicals because in solving for sides you have to take some square roots. So to deal with radicals, look for perfect squares. We've already talked a little about that. Simplifying by pulling them out, and I'll show some examples of that. Sometimes if you have a radical in denominator, we want to rationalize it and then cancel. So there's a few skills that may come up. Okay, here's a quick example. If this is 8 and this is a and this is 12, then we have a squared plus b squared is c squared. So a squared plus 8 squared is 12 squared. So a squared plus 64 is 144. Subtract 64 from both sides and you get a squared is 80. Then we take a square root of both sides. So we have a is rad 80. We want to simplify that. So what you do is you think to yourself, what's the biggest number that goes into 80 that you can take a square root of? And that's when it's helpful to know, be familiar with this list here. So we say, okay, 16 goes into 80. That's the biggest one on this list, which will work. And so since 16 goes in, we can split up 80 into 16 times 5, and rad 16 becomes 5. So it simplifies to 4 rad 5. So besides using the Pythagorean theorem, we also have what's called the converse of the Pythagorean theorem, which states that If a squared plus b squared is equal to c squared, we've talked about that, then we have a right triangle. However, if a squared plus b squared is greater than c squared, it's an acute triangle. And if a squared plus b squared is less than c squared, it's obtuse. And so here's some examples. We have the sides 5, 6, and 7. And so 5 squared plus 6 squared is greater than 7 squared. As we see, 25 plus 36 is greater than 49. Therefore, that's acute. If we do 4, 11, and 8, you have to do 4 and 8 is the short side, so make sure you reorder these. So 4 squared plus 8 squared less than 11 squared, because 16 plus 80 is less than 121. That would be obtuse. 8, 15, 17, that was a Pythagorean triple. This one actually is going to work. So this is going to be a right triangle. If we do 1, 2, and 4, well, this is a little tricky because 1 plus 2 is not bigger than 4, so this isn't even a triangle at all because it violates the triangle inequality theorem. Let's look at a little more practice over here. Okay, so in this case, we don't know one of the legs. So we're going to have x squared plus 7 squared is equal to 10 squared. So x squared plus 49 is equal to 100. X squared is 51. X becomes a radical 51. And this you can't simplify any further. Over here, 8 squared plus 14 squared is equal to z squared. So 64 plus 196 is z squared. This becomes 260 equals z squared. So z is the square root of 260. We've got to think about how we can pull something out of that. So what we do is write this as the square root of 4 times the square root of 65. And we end up getting 2 radical 65. Rad 65 you can't do anything else with. Let's take another look over here. We have a squared plus 3 squared is equal to 4 squared. Remember, this is not a 3, 4, 5. In a 3, 4, 5, the 5 is the hypotenuse. In this case, the 4 is the hypotenuse. So a squared plus 9 is equal to 16. A squared is equal to 7, so a is radical 7. If you're asked it for a decimal, you need a calculator. Otherwise, the simplest radical form, you have to do it the way I've shown. Okay, now an area problem. Area is 1/2 base times height, but we don't have the height. We have a base here, but no height. But this is 12, and we know this will be 6 because this is an isosceles triangle. So we can say 6 squared plus h squared is 14 squared. So h squared will be 14 squared, which is 196, minus 6 squared, which is 36. So that's equal to 160. So therefore, h will be the square root of 160. Square root of 160 is then equal to square root of 16 times square root of 10. So that's 4 radical 10. So now we have our height. So area is 1/2 times a base of 12 times the height of 4 radical 10. So this becomes 24 rad 10 centimeters squared when you multiply out all of these pieces here. Okay, skipping down now to using the converse of the Pythagorean theorem, 6, 9, 10. So we do 6 squared plus 9 squared. 36 and 81, that's going to be greater than 10 squared, so this one will be acute. 7, 24, 25. 7 squared plus 24 squared, 49 plus 576, and you'd want a calculator to help you with that, is actually equal to 25 squared, which is 625. Okay, that's 25 squared. So that's going to be a right triangle, so you have a Pythagorean triple there. For 2, 5, and 6, 2 squared plus 5 squared, 4 plus 25 is 29, which is less than 36. So that's obtuse.